Bright Tuty. Every student matters.
Now let us see a few questions based on graphical calculations. Let us see the first question. Now in this first question, what the examiner is asking from us is a driver of a car traveling at 52 kilometers per hour speed. Right. So the driver of the car is traveling at 52 kilometers per hour. He applies the brakes. Now we know that whenever brakes are applied, its speed is going to slow down. Why? Because after applying brakes, it will be the negative acceleration, which we call retardation or deceleration, that will be produced, which will slow this particular object down. And that is what is being mentioned. It accelerates uniformly in the opposite direction. Now acceleration in the opposite direction means retardation, right? The car stops in 5 seconds. Now based on the practice we have already done in this chapter, we know that whenever the car stops, an object stops, that means we are going to take its final velocity to be 0, and the time taken for getting the final velocity 0 is 5 seconds. So now if I relate, I am being given initial velocity, that is u. I know that the car stops, that means the final velocity v is given, and t, time taken, is given for this car. Okay. Now another driver going at 3 kilometers per hour in another car. Now there is one more car given to us, and that car is going at 3 kilometers per hour. So initial speed of that car is 3 kilometer per hour, means it is the initial velocity of that second car. It also applies his brake slowly and stops in 10 seconds. That car is getting stopped in 10 seconds. Car is getting stopped means final velocity is given to be 0. In 10 seconds means time is also given. So there are two cars. Either we can take car A and car B, or we can relate it to be U1, V1 and T1, giving the one number to car A, and U2, V2 and T2 for second car. Right. Now on the same graph paper, plot the speed versus time graphs. We have to just form speed versus time graph. Got it? For the two cars on the same graph paper, and which of the two cars travelled farther after the brakes were applied. Travelled farther means we need to calculate the distance travelled by both the cars. Then only we will be able to relate which car has travelled farther. Got it? Now first of all, we will relate what exactly is given to us in the question. Let us take it to be car A and car B. Right? Now the initial velocity of car A is given to us to be 15 kilometers per hour. We know that the velocities are to be taken in meter per second, its SI unit. So we need to change. Let us change it here only. It can be written as 52 into 1 kilometer upon 1 hour, or 52 into 1000 meters divided by 3600 second. Cancelling it out, I will get 18 here by cancelling it with 2, and 5 here. So this comes out to be 52 multiplied by 5 upon 18, or it will be equal to 14.4 meter per second. This is the initial velocity of car A. The final velocity is given to us to be 0 because it stops, and the time is 5 seconds. Let us talk about car B now. The car B, initial velocity of this car is 3 kilometer per hour. Again changing the units, it will be 3 into 1000 meters upon 3600 second. Right? Cancelling it out, we know that This we have studied earlier also, that kilometer per hour, whenever it is going to be converted to meter per second, the net effect of kilometer per hour will come out to be 5 upon 18. Right? Cancelling it out, and this will get 0.83 meter per second. 3 1 the and 3 6 the, it will be 5 by 6, coming out to be 0.83 meter per second. This is the initial speed. The final speed of this car is also given to be 0, because this car is also stopping, and the time taken by this car is 10 seconds. Right? Now let us first of all figure out what kind of graph will be formed, or how the graphical representation of these two cars can be done. Let us see. Now this is a graph that we have formed. In this graph, this is the y-axis, this is the x-axis. On the x-axis we have taken time in seconds, and the y-axis we have taken speed in meter per second. Right? This is what it was required, speed versus time graph. So speed on y-axis and time on x-axis. Right? Now if we talk about car A, then the initial velocity of car A was 14.4. So on the y-axis we have taken the speed to be 2, 4, 6, 8, 10, 12, 14, 16, 18 meter per second, and the initial speed was 14.4. Let this point be here. Right? Now after applying brakes, the final velocity becomes 0, and it becomes 0 in 5 seconds. So when I take on the time axis, this is in seconds, 1, 2, 3, 4, 5 till 10. In 5 seconds at this particular point, this particular car stops. So it will be a straight line will be joining these 2 points, and we have given these 2 points a name of A and B. This is the graphical representation of car A. Talking about car B, the initial velocity is 0.8 meter per second square. So if this is 0 and 2, let this point be 0.83 meter per second. Final velocity is 0 in 10 seconds. So in 10 seconds, the final velocity is going to be 0. So the motion of the car is represented by this particular line joining 0.83 mark and 10 second mark. Let us also give it a name C and D. So CD is the graphical representation of the car B. This is the first part of the question. We need to just show it through a graph. On the same graph we have shown it. Now the second part of the question remains, that asks which particular car travels farther after applying brakes. So we need to calculate the distance travelled by both the cars. Now in a graph we have already calculated how to calculate the distance. Now the distance will be area under the line, and the line here is AB. So if we relate this line AB, fine, the area under the line, how we are going to calculate? We are going to calculate this particular area, which is summed up as, we can say this is equal to area of triangle. Let us call it point. This is point D. Alright, D we have already given. Let it be E. So area of triangle EAB. This is E point, this is A point, and this is B point. And area we know how to calculate, half into base into height. This is the formula for calculating area of a triangle. Now the base part of this triangle is 0 to 5, T2 minus T1, which will be equal to half into base is 5 minus 0, that is 5, multiply by the height part. Height is from E to A. Higher value 14.4, it will be V2 minus V1, we have already discussed in the previous lecture. So it will be 14.4 minus 0, that comes out to be 14.4. Right? Cancelling it out, I will get this 7.2, and my answer will be 36 meters. This is the distance travelled by the first car, car A. Talking about car B, Now, if I want to calculate the distance travelled by car B, it will be calculated by area under the line CD. This is C, this is D, and the area is this part, or I can relate it that it is equal to area of triangle ECD. E, C and D. Now, once again, area of triangle is calculated by the formula half into base into height. So, the base part over here is this is ED. Alright. So, ED is T2 minus T1, that means 10 minus 0 means 10, multiply by height is EC. Once again, V2 minus V1, V2 is 0.83 minus 0 is 0.83, which comes out to be, cancelling it out and multiplying it, 0.83 into 5 comes out to be 4.15 meters. So, the distance travelled by the second car is 4.15 meters. Now, we see that after applying the brakes, this particular car A travels a distance of 36 meters and the car B travels a distance of 4.515 meters. So, we can very well relate which car travelled larger distance. Got it? So, this is how graphically we have to calculate. The first important thing we need to remember is that we have to find out the distance, and for that we need to just so called calculate our units from kilometer per hour to meter per second, then plotting the graph. After plotting the graph only we will be able to calculate the distance travelled. Fine. Let us see another question. Now, in the next question, this is the type of question or the graph which will be given to us. In the question, what exactly is asked to us is, this figure shows the distance time graph. This is on the y axis, it is the distance which is given in kilometers. This is y axis, this is x axis. Alright. This is the distance time graph of three objects A, B and C. Now, from this particular graph, we can relate that A, right, from 15 it is going to this particular point. If we draw just a perpendicular, then it will be 30. For B, it is starting from 0 to 30 and C is 5 to 30. Right. Now, what exactly we are required to relate in this question is, what exactly the examiner is asking is, which of the three is travelling the fastest? Now, which of the three is travelling the fastest? Let us see one by one. The first part, for knowing which of three is travelling the fastest, we need to relate the speed, and the speed is, we know that, calculated by the formula speed is equal to distance upon time. Got it? So, now we will calculate the speed of the first car A, the speed of second car B and the speed of third car C. To know the speed, let us see. For car A, if I talk about, the distance travelled by the car is equal to S2 minus S1 divided by the time taken, T2 minus T1. Let us see for car A, the distance travelled, this is S2, that is 30, and it has started from 15. So, it has travelled 30 minus 15, that means 15 kilometers, divided by, for travelling this 15 kilometers, it has taken a time of 25 and let us let it to be 30, right. Drawing a perpendicular here, 30 hours. So, this is the speed by which this is moving is, this is 1 by 2 kilometers per hour or 0.5 kilometer per hour. Talking about the speed of car B. Car B started from 0 and it reached 30, it reached it has traveled a distance of 30 kilometers, right. So once again, S2 minus S1 divided by T2 minus T1. For car B, we see that S2 is 30 minus 0, it has travelled 30 kilometers distance, and for travelling this distance, we relate that it has covered, alright, it has covered 15 hours. This should come to 15. Actually, with scale, if you will relate and draw a perpendicular, it should be 15, right. Okay. So I am just taking it through hand, that is why it is getting a bit deviated from actually where it should have been. So let us take this 15 hours. Now its speed is 2 kilometers per hour. Let us take the car C. Now if I calculate the speed of car C, same formula, we will see how much distance it has travelled in how much time. The distance car C has travelled is, it has started from 5 kilometers to 30 kilometers. That means 30 minus 5 is 25 kilometers. Divided by, for travelling it, it has taken a time of, it will be 25 divided by 25 hours. The speed is 1 kilometer per hour, right. So among these three, we see that the car B has travelled the fastest way. Got it? So this is the answer of our first part, that among these cars A, B, C, B is travelling at a faster speed, the fastest speed. Second part, are all three ever at the same point on the road? Now we relate that in this particular graph, car A and car C, they are meeting at this particular juncture, right. So they must be at this particular point. Car B and A are meeting at this particular point, and C and B are meeting at this particular point. So there is no actual point where they are all on the same particular point at any place. So we say that these three cars are never at the same point on the road. Next, how far has C travelled when B passes A? Now this is B, this is A, this line. So B travelling from 0, it is passing A at this particular distance 20, and at this particular distance 20, or at this particular time. If we relate, then we need to calculate how far has C travelled. So by this particular time, C has travelled a distance of 15 kilometers starting from 5. So it has travelled 10 kilometers by the time B is overtaking or passing A. Similarly, how far has B travelled by the time it passes C? B, we have to calculate how far it has travelled by the time it passes C. This is the line C, and B is basically just passing C from this point. Now at this point, if I draw perpendicular, I see that it has travelled a distance of 10 kilometers starting from 0. So once again, it has travelled 10 kilometers when it has passed C. Got it? So these are some questions that will require a bit of your observation, a bit of your conceptual knowledge, and then you will be able to do them. Got it? Fine? Good. Now let us see. In this next question, a speed time graph or a car, the speed time graph for a car is given to us. On the y-axis, it is the speed given to us, and the x-axis, time is given to us. Units are meter per second and second. Clear? This particular object is starting from 0. Then as time passes, it has increased its speed, fine, to this 6.5. We can relate 6.5 meter per second, and from there it is travelling at a constant speed, right. What exactly are the questions that the examiner is going to ask? He is asking how far, that means we have to calculate how far does the car travel in the first 4 seconds, the distance we need to calculate, right. How we are going to calculate? We know that speed is equal to distance upon time. So the distance travelled will be equal to what? S will be equal to V into T, where speed is denoted by V, time is denoted by T, and the distance is S. So, I repeat, S is equal to V into T. At the end of 4 seconds, we know that the speed or velocity of the car at this point, and taking this perpendicular correlating with this value on the y axis, we see that it is 6 meter per second. So, the velocity of the car is 6 meter per second at the end of 4 seconds. So, the distance covered will be 24 meters. Got it? Fine. Next, what he is asking is shade the area on the graph that represents the distance travelled by the car during the period. We have to shade the area that represents the distance travelled, and what we are going to do is, we know that whenever we are talking about distance travelled, this distance travelled is always area under this line. So, this is the whole portion that will be shaded as to calculate the distance travelled by the car. Got it? Fine. So, this was quite simple. Okay. So, this is basically a few questions. Next part or the same question is, which part of the graph represents the uniform motion of the car? Now, when the motion is uniform, from here this point we see that now it is a straight line, and the uniform motion is expressed in the form of we can say that after 6 seconds the motion of the car is consistent, it is uniform. Got it? Fine. So, these were the few parts which he was asking in our question. Alright. Right. Hope you have understood it. Please try to practice and try to read it. Thank you.